Welcome to PreMath. In this video, we have got this yellow trapezoid ABCD fully inscribed in a semicircle with the center O, as you can see in this diagram, such that the area of this trapezoid is 36 centimeter square. The base AB of this trapezoid is 6 centimeter, whereas this other base CD is 12 centimeter, and these two sides A, B and CD are parallel to each other, and furthermore this side AD is same as this side BC. And now our task is to calculate the area of this semicircle. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. Let's focus on this trapezoid ABCD. And let's recall the definition of a trapezoid. Sometimes we call it trapezium. A quadrilateral with at least one pair of parallel sides. As you can see in this yellow trapezoid, this side AB is parallel to this side CD. And now let's recall the area of a trapezoid formula. Area equals to height h times base A plus base B all over 2. And here in our case, this is our base A, this is our base B, and this is our height h. And moreover, the area of this trapezoid has been given to us as 36. So let's go ahead and fill in the blanks in this area of the trapezoid formula. So area of this trapezoid has been given to us as 36 equals to height h. We don't know that one. A value is 6 plus B value is 12 all over 2. Let's divide both sides by 9 to isolate h. So therefore our height h turns out to be 4 centimeter. So therefore the height of this trapezoid turns out to be 4 centimeter, as you can see over here. And here's our next step. I have dropped these perpendiculars AE and BF, as you can see over here. And these are the height of this trapezoid. So this height is going to be 4 centimeter. Likewise, this one is 4 centimeter as well. And now let's make an observation. We can see that we got this rectangle ABFE. This length AB equals to this length EF. If this is 6, then this has got to be 6 as well. So therefore, by symmetry, this segment DE and this segment FC is going to be the rest of the other one. That is going to be 12 minus 6 is going to be 6. If we divide 6 by 2, then this segment is going to be 3 centimeter. And likewise, this is going to be 3 centimeter as well. And now let's focus on this right triangle DEA. And now let's recall the Pythagorean triplets 3, 4 and 5. And we know in this triangle, this side is 3, this is 4. So therefore, this hypotenuse has got to be 5. So therefore, this side length AD is going to be 5. And likewise, this length BC is 5 as well. And here's our next step. Let me label this angle ADE as this angle theta. And now let's recall sine of angle theta is always equal to opposite side divided by hypotenuse. And in our case, this opposite side is 4 units, and this side, the hypotenuse is 5 centimeter. So therefore, our sine of angle theta is going to be equal to opposite side is 4 divided by hypotenuse is 5. And here's our next step. I am going to connect this point A with this point C, as you can see in this next step. And here's our next step. Let's focus on this right triangle AEC, whose this length AE is 4 and this side length EC is going to be 6 plus 3 is going to make 9 centimeter. So therefore we are going to apply the Pythagorean theorem on this triangle AEC. And here's our Pythagorean theorem: a square plus b square equal to c square. And in our case, our hypotenuse is this side AC. Other lengths are 4 and 9. Let's go ahead and fill in the blanks in this formula. So we got 4 square plus 9 square equal to side length AC whole square. Let me undo this square by taking square root on both sides. So therefore our AC length turns out to be square root of 97. So therefore we conclude that our this side length AC is square root of 97. And now let's focus on this triangle DAC, whose side lengths are 12, 5 and square root of 97. And now since we are interested in calculating the area of this semicircle, so therefore we must calculate its radius R first. And we know that this is the radius of this semicircle. Let me label this radius as lowercase r. And now our task is to calculate this radius r. And now let's recall the law of sines. A divided by sine of alpha equals to B divided by sine of beta. And now let's recall another version of law of sines. In other words, the sine rules is A divided by sine of alpha equals to 2 times the radius r. So therefore we are going to apply this formula to calculate this radius r. And here let's focus once again on this triangle DAC. Our this angle is theta, which is same as this angle alpha, and its opposite side is square root of 97, which is same as this side A. So therefore we can fill in the blanks in this formula. A in our case side length is square root of 97 divided by sine of angle theta is going to be equal to 2 times our radius r. And we know our sine of angle theta, we already figured out, equals to 4 divided by 5. So therefore I'm going to replace over here by 4 divided by 5. So therefore we can write this whole thing as a square root of 97 divided by 4 divided by 5 equals to 2 times our radius r. And now let's focus on this left hand side. If we simplify this fraction at the denominator, we can flip this one over. So this could be written as 5 times the square root of 97 divided by 4. And I'm going to multiply both sides by 1 divided by 2 and 1 divided by 2 on this side as well to isolate radius r. So therefore we can see this 2 and 1 divided by 2 is gone. So therefore our radius r turns out to be 5 times the square root of 97 divided by 8. And now our task is to calculate the area of this semicircle. And now let's recall the area of a circle formula. Area equals to pi r square, where r is the radius of this semicircle. And since we are dealing with the semicircle, so therefore the area of the semicircle is going to be this area, pi r square divided by 2. So therefore the area of this semicircle is going to be equal to pi divided by 2 times, I am going to substitute this r value as this one. So I'm going to write down 5 times the square root of 97 divided by 8 whole square. Therefore our area of this semicircle, let me go ahead and multiply this one, the whole thing, that is going to give us 2425 pi divided by 128 centimeter square. So thus the area of this semicircle turns out to be 2425 pi divided by 128 centimeter square. And in terms of decimal, this is going to be approximately equal to 59.52 centimeter square as well. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.